Math, here we go. What do we do? 2 through?
3 through 42.
Multiples of 3. That's right. I remember now. Number 3. The domain is x cannot be 4 or negative 3. And what are we looking for? Oh, asymptotes. That I didn't really read what the problem was first, and so I read the domain is x can't be 4 and x can't be negative 3, and then x is 4 and negative 3. And so I was very confused. But yeah, the asymptotes are at x equals 4 and x equals negative 3. Then 6, excuse me, x cannot be 4. It's got an asymptote at x equals 4. Number 9 is in the answer appendix. So let me flip to that page.
Maybe I did that when I was doing.
That'd be nice.
For the domain, you're writing an example before you word it.
What?
It's the domain for 6. Negative infinity to 4 union with 4 to...
Yeah. Yeah. Yes, in interval notation. That's interval notation. Is that what you meant when you were saying set builder notation?
Zero instead of 4, so I wanted to make sure.
Oh, I see. I see. Oh, but that was not one of the ones you did, because I can see some set builder notation on there. So you did some one way and some another way. I follow you. All right, 2, 5. Number 9. It's got a picture, so we need television.
I was also confused about the graphing part. Because it wouldn't go into the graphing calculator, and so I couldn't... I forgot that you can take calculus.
It could be in the graphing calculator. Hello? There we go. It could be in the graphing calculator. It was trying, well, no, I don't know. I really don't like the way TI does piecewise functions, because you kind of have to use a fraction notation thing. So it could be something with that messing with it. I don't know. I don't know why y'all are having trouble putting it in a graphing calculator. You're doing something wrong, because you should be able to put them in the graphing calculator. That should be a possible thing. But you don't really have to put it in the graphing calculator to be able to answer the problem, but you know, whatever. What?
The piecewise functions?
No, these functions.
I heard piecewise functions or something.
I was talking about piecewise functions because the way, like in Alexa's computer thing, calculator, you have to, when you put a piecewise function in, you put the function and then the if part goes like in a fraction. I don't know if it's the same in Garrett's, but it's like stupid. Like I don't understand why they decided to do it that way. It's just a really dumb way to do it, but that's what they did. So I don't think that should mess with like doing these, graphing these, but I don't know. It's been a while since I've typed in one of these type of functions into a TI-84 or 83. So I don't know. It should graph, all of your calculators should be able to graph these fine with no problems.
I just have to graph them.
So there is 9 with all its glorious details. Asymptotes at x equals negative 4, 5, and 1. X-intercepts at negative 2, 3. Y-intercept at 3/10. Domain is there. And the picture looks like that.
Okay, one moment.
In behaviors.
Okay, how do we figure out y asymptotes?
In the second video, but yeah, we can look at it.
Looks like a frowny face.
Is it just whenever there's nothing being added to the equation? Like on the side?
It's comparing the degree in the numerator and the denominator.
Okay, that part.
Yeah, it's all of that stuff. Let's get all the things, and then we'll come back and we'll do whatever questions we need to. Number 12 is here. Similar type of problem. I should have looked at, when I was assigning out problems, I should have looked at the answer key. Oh no, 15 will get some of the pieces. So I accidented into a good assignment.
When an asymptote is at 0, do we have to write the asymptote?
Yeah.
Yeah.
Yeah, because it's not that there's not an asymptote there, but there is an asymptote, because Because there isn't always an asymptote. Because it could be, because these could turn into a function with a hole in it, right? And then it wouldn't have an asymptote. It would just, it'd almost certainly be a straight line with a hole in it somewhere, right? Okay, number 15 is so pretty. We went through what, 18 maybe?
40.
Oh yeah, that's right. That's great. I love it. Which is why we did every thirds, because it's a lot. Oh my gosh. Hello, machine.
Is that a slant? Is there anything with slant asymptotes?
It doesn't really have a slant asymptote, I don't believe. Does it say it has a slant asymptote? No, it doesn't have it. So it doesn't have a slant asymptote. But it does have strange end behavior because something weird happens in this section. Right? So we may need to look at 15, possibly. We shall see. 18 is that guy. That's a fun problem.
This was one of the only ones that went in Precalculus.
Nice. It's probably something with the exponents and the fractions getting mixed up and when y'all are putting them in, if I had to guess. I don't know for sure. 18's there, and then 21 is over here somewhere. There he is.
Can you show me 20?
I can. Did you do 20 on accident?
Yes.
20 looks like that.
Yeah, right.
24 is that one.
Do we have to do asymptote x equals -3? Can we just write the vertical asymptote equals?
No, it's x equals -3 because it's a line. Because if it had an asymptote 3, then that would be like a dot asymptote or something. I don't know. Wouldn't make any sense. Number 26, no, not 26, 27. Oh, it's another picture. Gotta turn the page. Looks like this. Hello. 27 looks like that guy. Notice that there are some holes in there. And then 30 must be a word problem or something. Flip back over. Number 30, 30A would be 1 over x equals 1 over 30 plus 1 over 45 all over 2. And 30B is 36. 33 is plus or minus 2 times the square root of 3. And, plus, surely there should be a comma. Well, maybe not. Plus or minus 2 times the square root of 3 minus 2. And 36 is 4. And 39 is -6. And 42A is back over here again. It may be on the page I already took a picture of. It is. So it's right there.
That's not what I got.
And 42B is that one, and 42C is no, and possible explanation is that right there. Move our camera back around, and then we'll start on the questions. What are we going to start with?
Let's just do all of it.
I don't think that's feasible. 24?
Like,
Sure.
one from each like chunk of questions.
We can certainly
Yeah.
make an attempt at that. You said 24?
Yeah.
Okay, let's do 24.
That's a good idea. Can we just do one from each chunk? One from each type?
We certainly probably can.
Do we have any lessons due today, or is it gonna be with you?
Because we have a test Thursday, he said there was one.
Right.
Okay.
Yeah, test Thursday. Yay.
And
24. We is supposed to graph h of x equals x cubed over x plus 3. All right, so we should start with all of the asymptotes, right? What, if any, it has?
So the y asymptote says none, and the x asymptote is at -3.
you found this out how?
So the x asymptote is setting the bottom equal to 0 and solving it, and the top one is determined by the degree or how many x's there is. And since there's more x's on the top than the bottom, there's none. Here, look at my.
She found out the x asymptote by putting x plus 3 equal to 0
Right.
and then solving that.
Mm-hmm.
X equals 3.
And so the degree of the numerator is bigger than the degree of the denominator. So that means there aren't any horizontal asymptotes, right? What about slant asymptotes? How do we know if there's a slant asymptote?
If there's one more degree than the bottom,
Yeah. Which is not true, so there's not a slant asymptote.
One more degree as in one more.
Like if this was squared,
Oh, okay.
then this would have a slant asymptote. I don't know why I did it that high. That is never going to work.
And how do we know there is not a horizontal one?
Because the degree of the numerator is greater than the degree of the denominator. By more than one. Okay. So let's dot in our vertical asymptote. 1, 2, 3. All right. Let's start the next bit by doing some points. That seems reasonable, right?
Do we need to find the intercepts or just points?
Yeah, sure. Let's find the intercepts next. That's fine. Let's find those specific points. That sounds great. So, how are we going to do that?
X-intercept is setting the top equal to 0. The numerator equal to 0, right?
Not really.
just setting all the x's to 0.
I thought it was y.
That's the y-intercept. The x-intercept would be setting h of x equal to 0.
Oh, so it's the whole thing. Makes more sense, okay.
Okay. So let's do the h-intercept.
Oh, it's a 0.
And this is the y one, right?
Right? 0 cubed is 0, and so it's 0. Right? So we can go ahead and put a dot at 0, 0.
Nice.
To find the x-intercept,
Or y. Do we just do y?
we set h equal to 0.
We're also going to be 0. Well, one of them takes
Well, at least one of them is going to be 0. And unless this is like parabolic or some sort of sloopy-doop, it's going to probably have another, right?
Do we multiply by the conjugate on this one?
No, but that's a good thought. I understand where your brain's at. It's even easier than that. No, can't get to that 3 yet. No, not yet. Y'all are thinking more and less complicated all at the same time. How are you through? This is the only problem we've done. I'm confused.
I'm trying to go through and figure out what I don't and do know.
Ah,
Sort of follow along.
gotcha.
Multiply by its inverse. Not by its inverse.
I need to know what I don't
Yeah,
know.
by its inverse. Good vocabulary, remembery. Way to go. That's exactly right. That's the exactly right word.
See, I thought that's what multiply by the conjugate meant, but now I realize that's something else.
Yeah, we did the inverse of that to get rid of it. Which is why, Bree, that you set the numerator equal to 0. Because always, whatever's in the bottom is going to be multiplied times 0. And so it's always going to poof away.
So can we just do the numerator, or do we need to do that whole thing?
No, you can just do the numerator.
He's just showing you why you do that.
Yeah.
Yeah.
Cube root of 0 is still 0. And it's odd, so it's not plus or minus 0. It couldn't be plus or minus 0 because there's no such thing as minus 0. Even though on some older calculators you could get it to tell you that negative 0 was the answer. But
So there's just one.
But no horizontal asymptote. So something weird is happening over here. So there's not a slant one. How do we know there's not a slant one? What would have to be true for there to be a slant one?
Because there just needs to be a 1 difference.
Yeah, that's right. That's right. But something is happening. And this is the type of something that makes this the pre-cal versions of these instead of the algebra 2 versions of these. Because in algebra 2 versions of these, you pretty much have a few options for like how it's going to look. It's going to look like this, or the negative version of that, right? Or it's going to look like this, right? Or the negative version of that. Something, it's going to look like one of those probably in algebra 2, right? It's going to be something like that, right? But these different. So let's pick some points. Y'all should also we should also figure out what y'all are doing wrong putting it in your calculator so you can in the future put it in right. Figure out what's going on with it. Okay, so let's do some points here. Where's my? It looks like a positive 2 and negative 8? Yep. Why? Because it says what? Oh, okay. Well, let's do a little different than that.
What is
We're doing something different.
Reverse them, man.
what is the limit to how we can use our graphing calculators for this?
Oh, it's 'cause I
You can use them entirely. You need, like, what I've written on the board would need to be on your paper. Like this amount of stuff. Does that make sense?
So you have to find, so you just have to like prove all the asymptotes and the
Yeah.
zeros.
You have to show that you know how the calculator got some of the things that it got. But like building the table, I mean, you don't have to do that anymore.
Okay, so
You proved last year. You proved last year that you know how to do that, right? So now I mean, you have to write the table, but you don't have to like do all the like substitution, and I mean, because you know how to do that. Like, why are we torturing ourselves?
so we don't have to prove the table.
No. So I would pick like -4 and -8's probably, that makes sense. -4, -8, and then I would pick -2, and then I don't know, +6 or something. I don't know. That's probably plenty. We already know that this one's on there, so we may as well stick it on our table.
I thought you needed like 3 on each so you can make a curve.
Maybe. It kind of depends on what's happening with the picture. But because we understand kind of how asymptotes work, you can make predictive analysis for the rest. I mean, we really need like a bunch of points to have a real accurate one, but we're just trying to get a sketch.
Did I plug that in right?
I don't know. Let's find out. When we go to graph, wherever the heck the graph is, and we wait for it to think.
Mine thinks quicker.
Mine is very slow. Mine is very old.
Yours looks like a weird cubic thing.
I got this nonsense. Just
Yeah,
graph nonsense.
that's probably more like what it should look like. Let me punch it and see what.
I got what Garrett got.
What did you get?
It was yours.
Let me do it, and then we'll compare. I should also do it on. It may just be the window settings being crazy. That's possible.
Yeah, I set my window settings to like zoom way out for the X and for the Y.
What happens when I zoom out?
Let's see.
Mine's just showing up with the normal cubic function graph.
It's a cube.
That's kind of what theirs are looking like.
And my calculator does stuff differently than y'all's.
Mine's reversed.
That's possible.
Why is yours reversed?
I don't know.
I got to remember how to get to the graph part. How do I get to that on this thing, Aiden?
Mine's
What button do I push to get to the graph part?
Or the one labeled graph.
Was it,
That's what you would think.
so Aiden's is somehow,
Aiden, how do I get to the y equals? I don't remember.
do you have my calculator?
No, I have mine. That's the same model as yours.
I'm not telling you now. I think you go to type, F3 on the graph menu.
How do I get to the graph menu?
Just put that.
You press menu.
Oh, yeah. I forget. It's got the apps. Yeah. It's like Garrett's thing. It's got the, yeah. That's right. I forgot. And delete all that crap. Yes. Now we want to put in whatever we're putting in, x cubed, x to the 3. Oops. To the 3 over, whoa, what have you done? Speaking of skill issue, x plus 3 equals that. Draw it.
-8's the only one that comes up with like a fraction number.
What?
-8's the only one that comes up with a fraction number.
In the number you chose to plot.
And you guys are
Ah.
equal to 5.
I have to go to a different menu, right, to get the table. Is that right? Is that what I'm doing? Yep, it is what I'm doing.
Do we have to like, is there just like a hole?
Whoa, what the heck? Ooh, negative, then asymptote, then positive, or perfect, and then minus
Yeah.
one.
That's how these things like work.
So that's what I got. Y'all get the same thing?
Yeah.
Okay. Great. Then we stick all that in there, counting by tens, maybe. And then we graph the thing. We may want, if we go to like negative, since it's a little bit more annoying to do that on my calculator, what is it at negative 3.1?
Un momento.
'Cause I have to go in and change things.
A negative 3.1. Actually, that's not my error, but I get 3.1. It is 297.91.
So does
Point. Don't even care. We don't have the resolution to care about the thing. So it's always way up here. So you'd have to. So that's why y'all are. That's why on y'all's calculators you're only seeing the S curve part. It's because you have to zoom way out to get the other bit.
that's fine.
Right? And so it's like there's something up here happening. Something like that. And then this one is coming here, right? We would, and if we were trying to get a, what? 297 point something. We don't really care about the point something because we're not graphing at a scale where we're going to be able to see that. We're not even really going to be able to see 297. Zoom out a lot.
A lot.
Yeah, look at all these numbers. They're like, so set your window settings to like the Y part, the X part you can leave whatever you have, like negative 10 to positive 10. But the Y part, change it to like negative, well, actually I would change it so you can see up higher, like negative 2 to 500. And then you should be able to see it. Yeah.
What is that other video?
That I don't know.
Okay, can we do 18 next?
Sure. Let's do 18.
How like correct are we supposed to get a graph like this?
That correct. Dead serious. Like for this class, and if you take math in college, you will find both. I had professors in college that were like, just give me a basic sketch. They didn't really even care if there were numbers on it, nothing. Just like, do you know what this looked like basically? And then you write all your other stuff, like the asymptotes are this, and this is that, and this is the other thing, and all the different things, right? And so you write the stuff down, and then the graph, like, especially since you have a graphing calculator, I don't care if it's perfect. Like, who the heck cares? Like, great, you can push buttons in the calculator. I want you to see that you knew how this stuff got there, and then there's a sketch. It's great. It's beautiful. That's how I do. You said 18? Okay. 18, here we come.
This one wouldn't go on my calculator.
It's probably a parentheses / exponent / something.
This one pretty much looks like the other one.
I'm just getting confused
Because something's going on.
denominator.
Oh, you left me. Yeah. I'm so confused. All righty. This one's fun. I like this one. This is a good problem. Okay. Let's find our asymptotes.
Which one is this? 18?
This is 18.
The y asymptote is 0.
Since there's no degree on top, that means that there's less.
It's a degree 0.
on the bottom?
As a degree 0.
Okay, so it's less than the degree on the bottom.
True facts.
As an x, as a horizontal. Yes, y asymptote of 0. Right?
Yes. There's a y asymptote at x, what did we say? Has a, y'all keep messing me up saying y and x asymptotes. Break it, it's ruining my brain.
So we said the
Does it have let's start with the vertical asymptote. How do we find the vertical asymptote? Set the bottom to 0. So x squared plus 6 equals 0. Oh no. What's going to happen?
It's like the square root of 6, -6.
Yeah, so oh no. Oh no. That's going to have problems. That's going to have repercussions for the future.
is this the x asymptote? Because it
No, stop saying those words. You're throwing me off, and I don't even know what you're talking about when y'all keep saying x and y asymptotes. Horizontal and vertical. Vertical, horizontal.
I asked if we're supposed to say horizontal, vertical. You said to call it X and Y.
There's no way I said that.
Yes, you did.
I mean, who knows? I say weird stuff sometimes, so who knows? Horizontal, vertical. That's
X equals plus or minus pi squared root of 6.
true, true. So what does that mean?
We're gonna have a decimal. No.
Yeah,
It'll
yeah.
be an
Plus
I.
or minus? 'Cause it's
Oh, yes, sorry. I forgot to put plus or minus. You're correct. So what does that mean? Velocity of water nozzle. That sounds fun. What is this, lesson 2, 3? 5? That's what I was thinking. But I didn't think we were that far. But of course we are, because we have a test. I don't know where my brain was. It's fine. No problem. No problem at all. So what could that mean?
Then it doesn't exist because it's imaginary.
That's true.
Well, it exists because I graphed it.
No, the function exists, but that means that it doesn't actually have a vertical asymptote. So it's never going to go like and or and right? It's not going to have the vertical asymptote. That's not actually going to be there, right?
So the domain is just going to be negative infinity to positive infinity?
Yes. See if they agree with us. I think they do. Oh, help if I was on the right page, huh?
Did the problem say to state the domain?
Yeah. Yes, it did. The domain is all real numbers. Where's my little thingy-mabob? Yeah, there's my thingy-mabob. Okay. So, what is this graph going to look like? What's going to happen?
It's gonna do the line.
Does it have any horizontal asymptotes?
0.
It has a horizontal asymptote at 0. How do we know that?
Because x squared has more
The de-
whatever than x
yeah,
zero.
yeah, that's, yeah, I absolutely know what you meant. The degree on the top is less than the degree on the bottom. So it has a horizontal asymptote at y equals 0. Did you say what? Why? You what? You understand? Is there a confusion? That's why I'm asking.
Because you said everything to 0, 0 plus 6.
What does your note say about when the degree of the numerator is less than the degree of the denominator?
And then there's a horizontal asymptote.
Yeah. Horizontal asymptote. And how do you figure out where it is?
You set every x to 0. Then it's -4 over 6.
There's no 0 up here.
Yeah, you put that there on that one.
Actually, does it have a horizontal asymptote at y equals 0? Is that actually correct? What do you,
I think so. It looks like it.
it looked like it, but does it?
Should.
Let's
Find out.
So what do your notes say about finding it?
It says at the leading coefficient. What?
Oh,
Rational function, function of the form f of x equals a of x or b of x, where a of x and b of x
There's
is
not.
polynomial functions and b of x does not equal 0.
There's not an asymptote of 0.
Because they're not both polynomials.
Y equals 0. There is one.
There is 2.
So we're correct.
You are correct. You are correct. I just want to make sure we understand where, because like, if this was something,
It would still be 0. The top is less than the bottom.
yeah.
Making sure I'm understanding.
We don't have to have a horizontal asymptote at 0. It can be up or down some. But how would that happen?
Whenever they're equal in terms of the x's power, and then you take the coefficients and divide them.
There you go. Okay.
So,
Oh.
so
Glad I didn't have a coffee on there or something. We can do 21. I'd be, well, we didn't quite finish this, but you probably can finish this, right? It's gonna have, when you do your table and you start plugging stuff in and you graph it and you pull out your graphing calculator, it's gonna look like asymptote at 0, and then it's gonna have a little bump in the middle, right?
The bump goes down. Isn't this the top of the negative?
Oh yeah, I said it what it would be if this was positive. Yes.
I'm confused on how it's how it's 0, because there's a number on top and it's not getting canceled out, and it's like a negative fraction.
So there's a few different options, right? For when we're checking for asymptotes, for horizontal asymptotes. You're looking at the degree of the top. The grid top is 0, right? The degree of the bottom is 2. So if it's less than, it's always at 0. If it's the same, so like if this was x, if it was negative 4x squared, then it's the leading coefficients, that fraction, the top one over the bottom one.
You don't even have to check with math.
Right. There's no, yeah. 26, is that what you said? No, couldn't be 26.
21.
21 makes much more sense. I lost my little thing. Did we already do one in that section or no?
We did 24. We can do 21, but I thought we already did 24.
I did.
Let's potentially still pick that up, but let's try to do your first suggestion and make sure we get one from all the sections, and then maybe we go back and hit that one. That way we make sure we have something on all the bits. Unless there's a section that we don't actually need to do because we get it really well or something. Is there, so we did something from, yeah, so really only the solve the equations. Do we need to do one of those?
Yeah.
Let's do 39.
Is that what you meant, 39?
39.
You said 29, but I assume you meant 39. Yeah, let's do that, and then we'll come back and hit 21. Yeah, I bet we can squeeze both of those in. I bet so.
This is understood.
Incorrect in the notes
I don't know.
It's already been 45 minutes.
because you have
Time flies when you're having fun.
Not fun.
I'm having fun. I'm having so much fun that my foot decided to get excited and kill my podium. Garrett, you liked these. These were, well, I guess you liked the cancel-y ones better than these.
Yes, I did. But I was like, this is both fun.
I need help with these as well.
I don't remember how to do it. So.
Okay.
I understood 39 how to do it, but like the ones on 36 where it doesn't have a common.
Well, do we want to do 36 instead?
As long as it's similar.
We really are, if we're going to hit 21, we really only have time to do one or the other.
To 36.
36 does actually, but
36.
yeah, I'll show you. It's actually, 36 is one of those that when we get more and more complicated, you forget to see the easy stuff. They had a moment like that in Algebra 2 earlier today. We were doing systems, and the coefficient of all the letters was 29, and they didn't think about the fact that you could just divide everything by 29 and make your life a lot easier. And and Britton was giving me death stares about it, like, why are you blaming me? It's not my fault. Y'all could have remembered.
+1 times x to get that final number.
We do, yeah. The x, yeah, yes. 23 over x squared plus x. You can factor that.
It's x and
It's got a GCF.
Okay.
So the LCD is x times x plus 1. So the first one, when we go over, it would be 3x plus 3. Second one would be 2x. And the last one would just be 23. Find like terms, subtract 3. We've got 5x equals 20, and our answer is 4.
Where did we get all these numbers?
Okay, let me rewind. Okay,
No more step by step.
let me rewind. So what we did is we distribute this onto all the things, right? So when you do it on this one, the x cancels with the x. So all you're doing is distributing 3 into x plus 1.
So since it has x in the denominator, the x cancels out, so then it's just like
Right.
3.
And then when we distribute it onto this one, the x plus 1 cancels out. So it's just 2 times x.
Okay.
And then on this last one, everything cancels out, so it's just 23 times 1. Easy money. Now let's look at 21. Can't believe there wasn't any, maybe there was on one of the ones I didn't assign. Can't believe there wasn't any slant asymptote problems. That's kind of depressing. Slant asymptotes are kind of fun.
Maybe 21's gonna be slant asymptote.
No, 21 is not a slant asymptote. If the cube was on the top, it would be.
Are you adding up all the things? So there's 3 on the top anyway?
What do you mean? What?
On 21, isn't there 3 on the top because there's an x squared and an x?
It's the degree is the biggest exponent,
Oh.
not the number of terms. I don't know. 4x squared. 4x squared minus 2x plus 1 over
3x cubed plus 4.
x cubed plus 4. And it's g of x or something. Who knows? Who cares? H of x again. It's the h's. The h's are messing you up.
Okay, so the horizontal asymptote is 0 because the top degree is less than the bottom degree.
Mm-hmm.
And then I do not know vertical asymptote.
That y equals 0.
Is it another doesn't exist?
Vertical asymptote, no, it's not actually.
No, that doesn't matter.
Because cube, we can have a cube root of a negative, but not because it's odd. Plus 4 equals, so equals 0. So we end up with x cubed equals 4/3, right?
Yep.
And then we take the cube root of both sides. Oh, negative 4/3, my bad. That's what we were just talking about.
So then it's x equals cube root.
Which is approximately equal to negative something.
Something.
I don't know.
Oh, good enough.
Probably 1 point something, I imagine.
1.1006. Okay, so then that is the vertical asymptote. Is that the only one?
Yes, it is.
Okay.
Yeah.
It had a bad day.
All right.
It thinks
Generally, if the denominator, I mean, maybe not generally, this is probably like, we'd probably prove this is always true, but if the denominator has an odd degree, you're going to have only 1. But if it's an even degree, you could have more than 1.
Okay.
Because an odd degree, you're only going to get 1 answer out of it. And there's no slant asymptote.
Do we have time to finish this one?
Yeah, potentially.
It's only 12:19.
So we start to graph the thing.
Yeah, it had a bad day.
It had a bad day.
Yeah, I've seen this weird thing.
It rolled down a hill.
Well, and you know, you're joking, but that's kind of where you like see such a thing as this. we're talking about parent functions. That's all, you know, you're always, scientists are looking at the data and be like, okay, which type of parent function best fits my data? Let's try modeling it with this one, see if that works good, and let's try modeling it with this one and see if that works good, and all the things. So for our table, we want some to the left and to the right of this thing. So maybe -2 is close up to it. We may need to go like really close to it, so -1.2 maybe. And then one further out, let's say -8.
I guess I just need to sleep because suddenly everything's making sense.
That does tend to help. 0 and then 5, I don't know, whatever. Somebody tell me what numbers I need now.
-1.05 is my Drew. I gotta change mine. Say that in a second. -1.2 is
-1.2.
-16.39.
Wait, for what?
-1.2.
For -1.2.
Oh,
I just did one that was like really close to the asymptote to kind of see where it's, which kind of the end behavior of that, it's not really full end behavior, but like if we stopped there basically. -8 is what?
0.215.
negative.
And 0 is what? Okay.
4.25.
Do we need to
Wait,
double
then-
check y'all's two things? 4.25? And then 5 is what?
Sorry. 0.01847.
Yeah, I'm getting different numbers.
And then you might need a few more potentially because it does some weird things.
I don't know.
Suppose. And then
What number is this? What did you get for 5?
I messed up putting it in my calculator and gave up.
So he's not a reliable narrator in this example. All right, any fast questions at the end of the day?
can we figure out holes again?
Holes, so what would be the circumstance where there is a hole?
I don't know. That's why I'm asking.
It should theoretically be in somebody's notes.
A hole. Somewhere.
Unless I am remembering wrong and I didn't actually talk about it in that video, which is possible.
No, you
If
talk about it.
x equals a times x and b times x, b equals 0, and x minus c is a factor of x of a of x and b of x, and then
Okay,
There's a
so
hole
when
in-
you divide a of, so when you divide a of x by b of x and you get 0 as a remainder, there's a hole there?
That's how to find where the hole is. There is a hole whenever there is a hole. You know there's a hole if there's a common factor in the numerator and the denominator with an x in it. So like if we had, let me do a real simple example just to kind of do, and if we had x squared plus 4x plus 4 divided by x plus 2, we factor the numerator into x plus 2 times x plus 2.
Okay, so when your zeros end up being a plus and minus of a number, one of them is going to be a hole? Is that
No. If they have a common factor, like this does, see this is in common between the top and the bottom, right? If it has a common factor, it's gonna have a hole. And it's gonna have a hole where that common factor is. Like this particular graph would look like this. Be the line x plus 2 with a hole at -2. Yeah, yeah, yeah.
Let's just hope I get this
And-
test correct.
Yeah. So yeah, test on Thursday. As is always true, if y'all want the answers to the study guide or the practice test or any other problems you practice from this book, and you'd like answers to them to see whether you're doing it right, let me know and I'll send them to you.